everyone, I am Teacher Aryan. In today's video, I will show you how to do cluster analysis using SPSS. Now, why do we need to study cluster analysis? Well, cluster analysis may be used by researchers to identify profiles of persons or things and form a taxonomy. The profiles or classifications created from cluster analysis are then used in an inferential procedure to test hypotheses to determine, for example, how these profiles relate to some outcome of interest. Cluster analysis groups homogeneous units of analysis based on their characteristics or attributes using proximity or distance. It also uses characteristics or attributes to classify units based on patterns. Before we conduct cluster analysis, let us talk about the data. In my example, I use the profile of the employees. I have here the data which include the age, years in service, love toward job, expertise at job, and job satisfaction. Now, I have already encoded the data of 465 employees. We have here the ID number. Each employee is asked to respond on the following. We have here the age, and age is in scale measure. The work experience in terms of the number of years. It is also in scale measure. Now, they are also asked to respond on the statement, I love my job, in a 5-point Likert scale, where I indicated 1, I strongly disagree, and 5, strongly agree. They are also asked to respond on the statement, I am expert on my job and I am satisfied with my job, with the same scale. Note that these 3 statements are in ordinal measures. And here is the data view. As you can see, these are the columns created. We have here the ID number of the respondents, age, work experience, job love, job expert, and job satisfaction. Now, if we wish to see the equivalent scale of the descriptions, we just click these value labels in this menu tab. And there you go. Since we already have the data, we now proceed to steps in cluster analysis. Actually, there are several methods in cluster analysis, but in this presentation, we will use hierarchical cluster analysis. Step 1. Go to Analyze in the top pull-down menu, then select Classify, and then select Hierarchical Cluster. Step 2. Click the clustering variables and move into the variables box by clicking the arrow button. We will leave the default settings to cluster by cases and to display both statistics and plots. Step 3. From the hierarchical cluster analysis dialog box, click on Statistics. Select Agglomeration Schedule. Click on Continue to return to the hierarchical cluster analysis dialog box. Step 4. From the hierarchical cluster analysis dialog box, clicking on plots will provide the option to create different types of plots. We will select a dendrogram. Click on Continue to return to the hierarchical cluster analysis dialog box. And don't forget to unclick Plots. Step 5. From the hierarchical cluster analysis dialog box, click on Method. For this illustration, we will select the wards method. Then, we will select to use squared Euclidean distance. Click on Continue to return to the hierarchical cluster analysis dialog box. As we click the Save button, you can see we need to encode the number of cluster. Since we do not know yet the number of clusters as of this time, we only check None. Then, go back to Hierarchical Cluster Analysis dialog box. Click on OK to generate the output. Case processing summary will determine whether each and every data of the employee has been encoded completely, because there are some cases wherein the researchers might have missed encoding a particular response. In this case, it's 100%. Looking at the agglomeration schedule, we will now check the stages and the coefficients column to determine the number of clusters. We start our observation at the bottom part of the stages, which is 464. Now, what we are trying to look at here is the specific stage where we can observe a major difference between coefficients of the stages. For example, between stage 464 and 463, we get the difference of around 54,000. Then stage 463 and 462, there is a difference of around 7,000, while stage 462 and 461 has a difference of around 3,406. Then, stage 461 to 460, the difference is 681, and so on. By these differences, we see that there is a drastic change in difference of coefficients in stage 461. Now, to determine the number of clusters, we get the number of cases minus the number of stages. That is, 465 minus 461 equals 4. Therefore, we have 4 clusters. Going back to the SPSS in the hierarchical analysis dialog box, click Save button. Click Single Solution. Then encode the number of clusters, which is 4. Click Continue. As we observe in the SPSS data view, a new variable is created that specifies the clusters where the respondents are assigned. In here, respondents 1, 6, 7, and 8 belong to cluster 1, while respondents 2, 10, and 13 belong to cluster 2, and so on. Now, we can now use this cluster variable to determine differences between groups in each profile, using, for example, ANOVA. Now, if we are interested to determine the number of respondents in a particular cluster, we go to Analyze. Click Descriptive Statistics and select Frequencies. Choose the new variable created, which is the clustering variable, and place it in the variable box by clicking this arrow button, then click OK. In this example, since we have 4 clusters, we can say that cluster 1 has 199 respondents, which is around 42.8%, and cluster 2 has 71 respondents, that is around 15%, and cluster 3 has 96 respondents, that is 20%, and so on. So that's all for now for cluster analysis. After this, a researcher may now proceed to inferential statistics, wherein he or she may answer his research question examining the significant differences among groups using ANOVA or any appropriate test. And that is for another video tutorial. So that ends my presentation. Hope you find this tutorial helpful in conducting your research. This is Teacher Aryan. Thank you for watching.